So essentially I now have created a test procedure for that board that I showed you earlier. What I'm going to do now is show you the ScanExpress DFT tool, which tells us what the level of test coverage is. So I clicked this report icon here, and basically it launched my ScanExpress DFT Analyzer, and we can see there's report files that were imported from the TBG tool, and it's gonna this DFT Analyzer tool is gonna process those reports and tell me how much testability I'm going to get. So I click the Generate button. It processes those report files, and on the right here I now see statistical information in regards to the board. So I have a total number of nets, total number of 349 nets. Of those nets, there's 313 nets that have scannable pins on it. That means it has a boundary scannable controlled pin. And then it breaks down what's tested. Well, there's 320 nets that are fully tested. There's 11 nets that are partially tested. So the total number of tested nets is 331, or about 95% of this board. You can also view detailed information on the tool. So what I did is launch a View Reports button here, and there's different reports available to show you. This one, for example, shows you compliance enable pins. Now, compliance enable pin is a specific pin on a boundary scan device that must be held at a certain level in order for that device to remain boundary scan compliant. Usually, if it's driven in the opposite direction, that part internal tap controller will go into the reset state, and therefore you won't be able to shift data through that part. Now, by default, our tools will automatically constrain compliance enable pins to the correct level. But we'll do an analysis for you to make sure that your design ensures that these compliance pins are in the compliant state, meaning there's a pull-up resistor when it needs to be high, or a pull-down resistor when it needs to be low. Now, there's other parts, or there's other reports, like here's one that does a pin per device coverage report. So it lists all of the reference designators, tells you how many total pins there are on each device, tells you how many of those pins are completely tested, how many of those pins are partially tested, and then takes the combination of those two, divides it by the number of pins, and tells you basically the overall statistical testability of that part. And then there's just a bunch of other reports. I'm not going to go through them each one, but there's some reports that'll tell you what's being tested, the level of coverage that you're getting, whether it's fully tested or partially tested. Fully tested typically means you're testing for both opens and shorts on any given pin or any given net. And partially tested can mean a wide variety of things, like a net's being fixed at a specific level, so it can only be checked for stuck at conditions at the opposite state, or it might be being tested for shorts only, things of that nature. And then the summary reports, again, just showing you what the overall percentage coverage is for all the nets and all the pins of the board. So in a nutshell, that's basically what the DFT Analyzer does. From here, I'm going to